factor each trinomial. So if we look at these, well, let's look at that first example in A. I notice that this is a perfect square trinomial. And that, right, because the first term is the square of x and the last term is the square of 4. And the middle term fits the 2ab pattern. 2 times x times 4 is 8x. So if we have a perfect square trinomial, if we have an a square plus 2ab plus b square, it easily factors as a plus b square. Similarly, if we have a square minus 2ab plus b square, that factors as a minus b square. So in exercise A, I noticed that this was a perfect square trinomial, and so I can factor this as x plus 4 squared. But you have to first make sure that it is in fact a perfect square trinomial by checking that middle term. Alright, so exercise B, we have x squared minus 12x plus 36. Notice that the first term is the square of x, and the last term is the square of 6. Checking the middle term, is it 2 times x times 6? Well, 2 times x is 2x times 6 is 12x. That fits. Now, since it's a minus 12x, I can write this in the form x minus 6 squared. So x squared minus 12x plus 36 is equivalent to x minus 6 squared. 9x squared minus 24x plus 16. Again, I look at this and say, well, that first term's a perfect square of 3x. The last term's the perfect square of 4. Does the middle term fit? 2 times 3x times 4. 2 times 3x is 6x. 6x times 4 is 24x. It fits the pattern. And since it's a minus 24x, I can write that 9x squared minus 24x plus 16 is equivalent to 3x minus 4 squared.